Welcome back, and now in our study of sequences, we're going to go backwards. So rather than saying, here are the first four, or rather than us finding the first four terms, we're going to say, okay, well, we're given the first four terms, let's find the sequence representation. All right, so this is where things get to be a little tricky, and we really have to look for patterns, and mathematics is all about patterns, so let's see what we can figure out. Okay, um, so we're just supposed to find the nth term, and when we use this, we generally mean general form, not recursive form, but maybe you can find both just as a fun exercise. All right, so here, let's see, so I'm looking for an, okay, and an, so what I notice here is that the values 5, 6, 7, and 8, they're all going one up, or going up by one each time as I go through the sequence, right? But there's also this alternating factor, right? So if I, okay, so what I'm imagining is that I'm starting at 5, right? My first term starts at 5, and then I add n, right? But wait. Okay, 5 plus n. If I did that, and n is 1, right? That would be 6. So I actually need to start at 4, okay? And then, okay, so forgetting about the positives and negatives for a minute, if I do 1, I get 5. If I do 2, I get 6. 3, I get 7. 4, I get 8. Yeah, so what I'm doing now is I'm checking, and that's always a good thing to do once you have an idea, okay? But now, I need to factor in that the odd numbered terms are negative, okay? And so what I can do to that is, remember we had that alternating factor that we had discussed at the end of the first video? Yep. So you might need to go back, rewatch that, but to get the odd numbered terms to alternate, we need to have that -1 to the n in there, okay? So I think this is going to produce what we needed to do. If you want to check, I'd say certainly do it, okay? All right, for this next one. Okay, so there's 1/3 in the first term, 1 times 2 in the second term over 9. And then in the third term, I have 1 times 2 times 3, all over 27. Okay, so there's a lot going on here. An equals, okay, there's clearly a fraction. Okay, now I'm going to take it a step at a time and figure out what's going on in the numerator, what's going on in the denominator. Okay, and if it's easier again for you, you can imagine that, you have your n and an table, just like you would an xy table, and say this is term 1, 2, 3, and 4. Okay, doing that sort of analysis strategy could help you say, okay, well, there's a 1 here, there's a 1 there, there's a 2 here, there's a 2 there, okay, so on and so forth. What I notice is that the numerators seem to terminate with whatever the term number is, and there's multiplication going on between successive terms. So that seems like an n factorial sort of approach to me. Okay, so 1 factorial is 1, 2 factorial is 2, which is 2 times 1. 3 factorial is 3 times 2 times 1, which is 6. And then 4 factorial is 4 times 3 times 2 times... Okay, that seems to match. And the denominators, this is 3, 9, 27, 81. Those are all powers of 3. So I'm thinking that this is 3 to the n. Okay, does that fit? Sure does. Okay, so take a guess, try it out, and then modify as needed. All right. Next one in the lower left. I want you to pause the video, try it out. This one, yeah, try it out. I'm just going to say start there. Okay, so again, if I'm looking at these, this is my first term, second term, third term, fourth term, and then this is my sequence value an. All right, so then what I'm noticing is that, okay, so an, I notice that 13, 26, 20, okay, so I'm looking at the denominators, and that's the first thing that stands out to me, is that those are all multiples of 13, so it's 13 times n. 13 times 1 is 13, 13 times 2 is 26, 13 times 3 is 39, 13 times 4 is 52. Okay, now the next thing is what to do with the denominator, or the numerators. The denominator, or the numerators rather, continually decrease by 3. So it's like I'm subtracting 3. Okay, so I know there's a subtract 3, and I subtract it based on the number of time, or the sequence value I'm in. And now if I do this, right, I can say, okay, well, if n is 1, I'd get -3. But I start at 4, right? Okay, so -3. So then if I need to start at 4, that's 7 more, so I need to tack on 7 and then subtract 13, or subtract 3. Does that work? Yeah, actually. So this is going to be the sequence for this one. Okay. Again, my strategy here is take a look at it, see what you see, try it out, or try writing a form for it, and then if it works, great. If it doesn't, try again. Okay. For this last sequence, okay, I have the sequence values bolded that it would reduce to, but I have the unsimplified form there as well in case that is useful. Okay. What I notice is that, okay, so this would be 1 over 1. There's a negative on the even terms, right? So a negative on the even terms is going to be -1 to the n plus 1. Okay, so there's that going on. The denominators 2, 6, 24, 120. That's 2 factorial, 3 factorial, 4 factorial, 5 factorial. So the denominator appears to be n factorial. Okay, because this would be term 1, term 2, term 3, term 4, term 5. Okay. And then the numerators are 1, 4, 9, 16, 25. And the term number is 5, 4. Okay, so that is n squared. Okay, and that is going to be my answer for this one. Okay, so sometimes it is just you need to stop, think, look at the numbers, think about the relationships between the term number and each of the values, and go from there. All right, these are tricky and they take time, so be patient and try a few different things out and see what works.